Swagatam, cover the mathematics classes. This is your Murali Krishna. We are discussing the chapter set theory. Now, the present topic is Venn diagram. Present topic is Venn diagram. And it's very, very important concept. What is this Venn diagram? We know how to represent a set. How many ways are there? There are number one, roster form, and number two, set builder form, and another, the way of representing the set is Venn diagram method. What is this Venn diagram method? It is just a pictorial representation of a set. Again repeat, it is a pictorial representation of a set. So what is the meaning of pictorial representation? Very simple. In this Venn diagram, we use any polygon. Most of us we use rectangles and circles. Of course, you can use triangles also. I have a set. For example, A is equal to, I have set 1, 2, 3, 4. Simple. This is roster form. In Venn diagram, what we do, simply we draw a circle. We name it as A, and inside we write all the elements. That's all. So this is Venn diagram representation of the same set. Simple the concept. We can use the same, instead of circle, I can go for triangle also. 1, 2, 3, 4. Or you can use a rectangle. Here set A, 1, 2, 3, 4, and so on. You can use any closed geometrical figure as a picture to represent the set. But in maths literature, in most of the textbooks, we use rectangles for the universal set and circles for subsets of that universal set. So again, I repeat, a triangle for universal set and a circle for subset. For example, in a particular context, I have U, universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And let's say A is the subset of it, which contains the elements 1, 3, 5, 7, 9. Of course, A is subset of U. So, using Venn diagram, how we can represent these two? I told you, in Venn diagram representation, we use a rectangle to represent universal set. This is U. Now, to represent this circle, this set, we draw a circle inside the rectangle, that is A. How to start? First of all, fill the elements of A inside the circle. Fill the circle with the elements of A. What are they? 1, 3, 5, 7, and 9. Whatever elements are there in U other than A, you just write outside of the circle but inside the triangle. What are they? I do write 1 on is there, 2 I do, 4 I write 6, next here 8, actually is 10. There is no restriction for the place of the element. Either you can write all 2, 4, 6 that side or this side, anywhere you can write, but outside the circle and inside the rectangle. This is very, very important point. Now, if you have a close look at this diagram, look at the only rectangle, ignore the circle. Look at the rectangle, focus only on rectangle, ignore the circle. Then you find all the elements of U inside the rectangle. Now, focus on only circle, then you find all the elements of A. And from this one, you can find a lot of things we can find. Using this Venn diagram representation, you can do all the operations of the sets like union, intersection, difference, complement, lot of things, distributive properties, everything you can prove using this Venn diagram. Please take it. Venn diagram representation. Yes. Using Venn diagram, you can find A union B, A intersection B, A minus B, and B minus C. All the operations I will show you by taking an example. Let A is equal to, you have 1, 2, 3, 4, 5. And whereas B is equal to, you have 4, 5, 6, 7. Now, what is A union B? I am writing here. A union B is equal to 1, 2, 3, 4, 5, 6, 7. What is A intersection B? A intersection B. Now, what are the common elements of A and B? 4 and 5. Next one, what is A minus B? That means that elements which belongs to A and but not B. What are they? 1, 2, 3. Similarly, what is B minus C? Four and 5. You can represent all these A union B, A intersection B, A minus B and B minus A in one representation of Venn diagram. As usual, I draw. So Venn diagram representation. First we draw a rectangle. Let it is U. Then draw two overlapping circles inside the rectangle. One circle represents A and other circle represents B. Why overlapping? Only to show that they have common elements. So this part represents this part. If you observe carefully, this part belongs to A and as well as B also. So the common part, the overlapping part represents A intersection B. First, fill A intersection B using elements 4 and 5. Next one, in the A, after writing 4 and 5, remaining elements are 1, 2, 3. Now come to B. B, 4 and 5 belongs to B also. After writing 4 and 5, remaining elements are 6 and 7. So this is Venn diagram representation. From this picture, what you can identify? Number one, you can identify A union B. A union B. 1, 2, 3, 4, 5, 6, 7. the whole one is A union B. Second one, the common part is 4 and 5, A intersection B. And next one, A minus B, that is only belongs to A, 1, 2, 3. Next one, B minus A only belongs to B, 6 and 7. Please write down. Now generalization of A union B, A intersection B, A minus B, B minus A complement, all these things in Venn diagram. How? Now first of all, how do we write A union B using Venn diagram? A union B using Venn diagram. Very simple. First you draw a rectangle. We assume that the both are intersecting, so overlapping part. This is A. Now I am going to show you how to represent the A union B in general using Venn diagram. Listen carefully. First of all, you choose either A or B. Fill, shape that set A either with the horizontal lines or vertical lines. So what I do? I draw horizontal lines to shape A. Now whatever lines I use for A, I am going to use same lines for B also. That means horizontal lines. Now the whole picture represents A and B. Here the box you have write A union B is equal to some box horizontal lines. That means whatever part is there in the diagram shaded by this horizontal line represents A union B. This is number one. Number two, A intersection. As usual, draw a rectangle. This is U. Just simply draw two overlapping circles. Now, AB. I want to show intersection of the two sides in the diagram. For this, what I will do, shade A with horizontal lines. Of course, you can use vertical lines and slant lines also. That's up to you. But you have to use only one line, type of lines. Now B, this time what I do? I use the horizontal lines, so I shape B with the vertical lines. So completely contrast. Complete contrast. Now, wherever the both lines are meeting, the common part that represents A intersection B. So I write here A intersection B is equal to some box here, horizontal lines and vertical lines. Now, next one, I go for A union B union C. So in this case what I do, I draw a rectangle U. I have two circles, so I need to draw three overlapping circles. 1, 2, 3. This is A, this is B, and this is C. Now, A union B union C, I need to fill all the sets with the same type of lines. That means, if I use horizontal lines for A, I have to do same lines for B. and C also. So wherever you find the horizontal lines, that part represents A union B union C. So this is A union B union C is just a rectangle with horizontal lines. Now I am going to show you A intersection B intersection C now. A intersection B intersection C. A intersection B intersection C. For this, as usual, draw rectangle. Let this U, 3 overlapping circles. Like this. Now I want to fill A with horizontal lines. Horizontal lines. So I am shading A with horizontal lines. Next one, choose any contrast lines for B. I go for vertical lines. So I am shading B with vertical lines. Next one, you choose any other third type of lines. I use slant lines. I use for to represent C. So horizontal lines represents A, vertical lines represents B, slant lines represents C. Wherever the three lines are meeting, wherever the three lines are meeting, so the reason where you find all the three lines, then this is represents A intersection B intersection C. So this is A intersection B intersection C is equal to one small box, and write first horizontal lines, then write vertical lines, then write slant lines. This is A intersection. Next one, I can show you A complement also. D markers, everything. Now, please, these are the 4 diagrams, fundamental 4 diagrams to represent A union B, A intersection B, A union B union C, and A intersection B intersection C. Please copy this. We can prove all the properties of union of the two sets, intersection of 2 sets, difference of 2 sets, complement, distributive laws, everything we can prove using Venn diagram. So we can prove A union, I am writing the properties. First, A union B union C is equal to A union B union C. Next one, we can prove A intersection B intersection C is equal to A intersection B intersection C. You can prove. It's very easy. But I want to focus on distributive laws. I prove the distributive laws using Venn diagram. How? A union B intersection C is equal to, first of all, A union B intersection A union C. I am going to prove these using Venn diagrams. First of all, I will make it 2 parts. A union B union C. I am going to draw one rectangle, and I draw 3 overlapping circles. A, B, C. Listen carefully. I am combining 2 sets. A and B intersection C. A and B intersection C with the help of union operation. When you are combining two sets with union, you have to shade the first set either with the horizontal lines or vertical lines or slant lines. Same type of lines you have to use to shade second set also. So here A union B intersection C. First I focus on B intersection C. Where do you find B intersection C? Here I will find B intersection C. I use horizontal lines to represent B intersection C. Whatever lines I am using for B intersection C, I need to use same lines for A. So just extension of the horizontal lines. So this the lamp type diagram represents A union B intersection C is just a lamp type, but of course horizontal lines. Next come to this side. This side. Again same rectangle. Of course U, writing U is a W. Three overlapping circles. Number 1, number 2, number 3. ABC. Now here also I am combining two sets with the help of intersection. I am applying intersection operation on the two sets A union B and A union C. Whatever lines I use for A union B, suppose horizontal lines, then I need to use vertical lines or slant lines for A union C. So first what I do, I represent A union B with horizontal lines. Where you find these two circles represents A union B, so I use horizontal lines to represent A union B. Next one, A union C. I use vertical lines for A union C. Now I told you intersection is common part. Which is a common part here? This is again I got a lamp. So look here, these two shapes are same. So therefore A union. So by looking at the diagram, easily I can say A union B intersection A union C is equal to wherever vertical lines and horizontal lines used. If you observe carefully, this type of shaded part and this type of shaded part both have same shapes, lamp shape. Therefore, they are equal. This is number 1. So I can write here. Therefore, A union B intersection C is equal to A union B intersection A union C. Next come to another second one. A intersection B union C is equal to A intersection B union A intersection C. Here also, as usual, I draw the first one, two rectangles. This is for U, as usual, 3 overlapping circles. Next one. Here, A intersection B union C. I am combining two sets, 1 and 2, it is a of intersection. So again repeat, whatever lines I use for A, I need to use opposite contrast lines for B union C. First for A, this is A, B and C. For A, I will do horizontal lines. Next one, I am going to use vertical lines for B union C. B union C means these two, so I am going to use. So horizontal lines represents A, whereas vertical lines represents B union C. Let us see it is going to happen for that side also. A intersection B union C is equal to, I have here vertical lines, horizontal lines. Come to that one. Another one. Again, a rectangle, of course, you can use square also, union. Here also again, 3 overlapping circles. A, B, C. Now, A intersection B is one set. A intersection C. A intersection B is one set. A intersection C is another set. I am applying the operation union on that one. So first I focus on A intersection B. C is nothing but A intersection B is a common part. Next one, A intersection C. I need to use same lines for A intersection C also. All this is. So this entire horizontal lines represents A intersection B. So I have A intersection B union A intersection C is equal to A, sorry, box, only horizontal lines. Now if you observe carefully, A intersection B union C is these type of lines, where the lines, horizontal lines and vertical lines meet. This part, I am highlighting that this part is A intersection B union C, and this is horizontal line part. Now, if you observe carefully, these two have same shade, so I can say, therefore, A intersection B union C is equal to A intersection B union A intersection C. So, distributive laws are proved using Venn diagram.